Okay, CNN as one of the deep learning approach. Again, let me remind you that in this syllabus we only introduce to you with what we call as a CNN or convolutional neural network, which is one approach, one of the common and popular approach in deep learning approach. Like I said in during the introduction to deep learning, we have a lot of approach which can be considered as a deep learning approach, but the one that we highlight in this course is only CNN. Okay, so let me go back to this. Yep, not this one. Let's go back to the previous whiteboard. Okay, again, I just mentioned this one in the introduction there, and then in our courses, we when we talk about deep learning, it's also known as a deep neural network. We don't talk or we don't discuss the whole definition over here. We only focus on the definition of deep learning in terms of this side only. Means that when I said deep learning, it's also referred as a deep neural network. And then what is actually deep neural network, and then what is the difference between the deep neural network and the previous one, the one that we learned in ANN. The ANN, we only focus only the network, the neural network, which consists of one hidden layer, and so another name for that is also known as a shallow neural network. And then once you increase more and more hidden layer, then it become a deep neural network. And then again, deep neural network itself, if you extend, if you do some, actually the architecture is extended from this shallow. If you increase more and more deep, if you are increasing more and more hidden layer, then it become deep neural network. And of course, that is also not so practical in implementing in your computer. Again, even nowadays your computer have a very high speed, can do all the parallel job very quickly, so then you can implement neural network with more and more deep more and more hidden layer. Then it's still not so practical as if you are increase more and more hidden layer with similar. It will also increase the number of parameter. Number of W will keep increase, and the number of bias will increase. So the learning process is quite heavy there. So that's why instead of using the original deep neural network, they introduce to you with what we call as a convolutional neural network, which is a little bit faster than the original deep neural network, which is come from the ANN that we learned before. Okay, so we will discuss later why they call it a convolutional neural network instead of just name it as a deep neural network. Why they call it as a convolutional neural network? You can see the operation is a little bit different, from just a small difference as compared to the original artificial neural network. This is some of the example implementing the deep learning in nowadays in many area, especially the CNN. So we can see that the deep learnings are everywhere. So in terms of classification, I think this one you already familiar. What is the meaning by classification? Is that the input is image, the output is the image label or interpretation. If that is the application, then you can consider that as a classification system. Okay, and then you also have the retrieval. Retrieval is almost similar to classification. It's a little bit just a little bit tuned on the output part. Okay, when you talk about retrieval system or image retrieval system, is that it's like your, I think in Google you have the most popular example of retrieval is Google searching. Okay, Google searching, that Google searching that you already you use every day is called as a text retrieval system, meaning that the input is text. Once you give some keyword, the Google will search for you what is the where is that text inside the website, any website in the world. Okay, That is what the Google search engine do for you. But actually, in Google, you also have one. I forget the features there. You can, instead of key in the keyword, you can also upload the image you have, and the Google will search any image in all website around the world which is almost similar to the input image that you give. So that is called image retrieval. Okay, so the one that used by key in the text is called a text retrieval. The one that the input is image is called an image retrieval. So that is one of the example where the deep learning have been used, because when the query, the input or the query image is flower like this one, and then the Google will search the similar flower inside any website around the world. If you give the input is the picture of elephant, and then the Google will find any image inside any website around the world which have elephant. So that is called image retrieval, which is a little bit different from classification, because classification, the input is image, the output is just label of the image. Okay, but the retrieval is that the input is known as a query. If the query image, given the query image, the system will search the similar image inside the database or inside the any website around the world. So that is very popular for search engine like Google's. And then application like detection. Okay, what is the difference between detection and classification? The classification, the input is image, the output is label of that image, while detection, the input is the image, the output is the label of the object inside the image. Okay, you can see that we don't label the image, but we label the object inside the image. So that is the detection. For example, this image, then you label the driver, the person, the bus. This image, you label the object. Okay, this one is boat, this one is a person, this one is a person. And from the image you label the object. This one is a cat, this one is dog. But for classification, you are consider the whole pixels there. Input is image, the output is label. So that's why, let's say if you just give this one, and then let's say this is the input of your of system over here, then the classification might fail because you have two object here. So how do computer interpret this one? Or maybe they interpret as animal, for example. Okay, because they cannot say dog and cat because both will have inside the same image. So but you are doing a classification job, so maybe the computer will interpret as animals. Okay, so it's different from this one. This one, because you only have the one object which is dominate the image, so the rest is just a background, a plain background there. So that's why if you give this one, I don't know, you can see that this is one of the good example. Okay, the input consists of dog and cherry, and then if you apply the classification system, the computer said it's a cherry. So because it might be this one is dominate, if you can see that, I think this one is around 50% as compared to this pixel belong to dog, the rest is background. So that's why this classification only choose the one that dominant inside this image. So that is the job of that is what the classification do, or image classification do. But for detection is a little bit different. Instead of you are find or you are label the image according to what pixel dominant inside the image, you are labeling, or you are classifying, you are judging all pixel belong to object. Doesn't matter you have how many object inside the image, then you need to entertain one by one, means that you need to detect one by one. You cannot just select the most dominant and then interpret that. So that is the difference between classification and detection. And then we also have segmentation. Okay, segmentation also have been deep learning is also now in a, or especially in CNN, is very progressive in segmentation instead of image segmentation that have been learned in image processing class. I think this one for those who do who take the image processing class, they also learn about image segmentation, but that segmentation is very old. The first is very old, and then there's not involve any learning algorithm. It's a very plain where they try to find out the algorithm that can differentiate between pixel belong to region of interest and differentiate it between pixel belong to background, because they want to highlight only the pixel that belong to region of interest. And that job has been also been replaced with CNN, where CNN based approach also have a capability to learn to select which pixel belong to object and which pixel belong to background. They try to process pixels wise and then choose which one is belong to object, which one is belong to background. So that is segmentation. So you can see that from the classification. Okay, you can see that from classification, the input, the process is the whole image. Okay, this is one way to differentiate between classification, detection, and segmentation. Classification, you consider as the process is the whole image. For detection, the process is just the object inside the image. And for segmentation, the process is a pixels wise, means that every pixels wise means that every pixel you are classify as whether it's belong to object or whether it's belong to background. But this one, you take one crop of object, you classify what is it inside the image. But this one, you take the whole image to classify. So every image here, okay, I use it. Even I use the word classify. That does not mean classification. Okay, for classification, you classify based on the whole image. For detection, you classify based on small block or small region inside the image. But for segmentation, you are classify based on single pixel itself, whether it's belong to object or whether it's belong to background. Okay, so every part of this system have a classification process or learning process, but the application, what things you process will make it, name it differently, because if you are classifying the whole image, it's called classification. If you are classifying the object inside the image, it's called detection. And if you are classifying the pixel, whether it's belong to background or whether it's belong to object, it's called segmentation. Okay, so this is other examples there. You can see that this is one example of detection, same like this one, which have been used in our car, the modern car today. That's why company like Nvidia, okay, before deep learning becomes so popular, they just sells the graphic card, the computer graphic card for what? For playing video game and so on. But nowadays, this company become more and more popular and get benefit from the deep learning, because now even car also need a graphic card, because they want to design a deep learning embedded system. Okay, of course, to train that deep learning or to run that deep learning, you need a very high speed computing. So that, and it can be executed parallelly. So that is where the graphic card is preferable to do that. So now they are selling the graphic card not for playing game, they are doing it for developing a smart car today. So for example, I think there's a many new car nowadays have a capability to automatically brake if you don't brake. If you let's say they find out there's a pedestrian in front of your car, so that is where the deep learning is actually processing. They try to classify, is it a car or is it a pedestrian. Once they detect the pedestrian in their view, then it will automatically brake even you don't brake. You because if you, it's just depend on you, it might be accident might happen. So that's why the modern car use something like that. Okay, even the Facebook also use the CNN to recognize your face. That's why when you capture your image, you upload into the Facebook, then the Facebook can tag your face. Not just tag your face, it can recognize this face belong to who in your friends list. So that is where actually the deep learning happen, especially in implementing the CNN. So that's why in our syllabus we just I just introduced to you with CNN. Of course it's not enough, but at least we learn some technique which is nowadays very popular in many application in around the world. So hopefully later when you already know the deep learning, you already know the CNN, you'll be able to do some self-learning on other approach in deep learning. Okay, so character recognition is similar to image classification, still also using a CNN. And then yeah, post estimation, this is something related to, you know, nowadays when they are playing video game by using, I think Xbox are using what we call as a Kinect, but the Kinect, they don't use the color image, they use a depth image. So that's why they can at that time without deep learning, they capable to recognize your gesture and so on. But with deep learning now, even without using Kinect, you can use a webcam and so on. You'll be able to recognize your posture, and maybe one day you can interact with your computer by using your gesture, and then you can play your Xbox, for example. Okay, and then the computer games. I think most of the computer games is not CNN. Okay, this one is the example. I think most of the computer game, they are using reinforcement learning, like the one who beat the AlphaGo, that is also using the reinforcement deep learning. Okay, cell cancer detection also based on CNN. Chinese character recognition is also based on CNN. So that's why we try to introduce with CNN. Okay, and then neural tissue segmentation, CNN. But of course in our syllabus, I only introduce CNN for classification, not for detection and not for segmentation. Okay, so then you can with that knowledge, I think you can do something like this, character recognition. You can do this one, classification. And you can also do Chinese character recognition. This one cannot be done because this one is detection. Road sign recognition you can do. Okay, because based on the whole image, you interpret, you label the image. But this one you cannot do because it's labeled based on the object inside the image. And text processing, yes, this one we cannot do because of we will focus CNN based on image only. So that's why we don't process that one. But just for your knowledge, CNN also can be implemented in text mining as well as speech processing. Okay, this is an example of speech processing. This one can be done, but you need a little bit process your data, your speech signal. So because this one is they process, they're using a certain process to convert your 1D into 2D like this, 2D because 2D signal like this, because of now it's look like an image. Then you can implement the CNN for classification to do that. But of course that is not we will not do that because of we need another process to implement our CNN. Okay, even in this I forget to just to remind you that there's also one assignment related to this one, where the input is image, we try to classify. So that's why in deep learning introduction to CNN, we only do for image classification, where the input when the input is image, we try to label the image or try to interpret the image by using the CNN. Okay, this one is, I think if you go to the Kaggle website, Kaggle is one of the website that everyone share the dataset. You can find out there's a one dataset called whale recognition. Okay, whale recognition is an image classification. So because the input is image of fish, and then you need to recognize which one is belong to whale and which one is belong to other fish. Okay, image captioning is a little bit complicated because this one is a combination between CNN and other deep learning, which is called LSTM, low short term memory. So of course that is also a part of it is a CNN. So that's why the example of application in implementation of CNN is image captioning. Means that image captioning is more complicated than image classification, because image classification, the input is image, and then you just label. For example, this one, if you pass into image classification, it will say that rider. Okay, it labeled as rider. But image captioning, you give the input is image, it will provide some text describe that image. It's a longer text. It's not one or two word. Okay, if you do image classification of this one, it only said this is image of car, one word car. But image captioning, you give the input is image, the output here is a sentence describe this image. A yellow school bus parked in the parking lot. Of course it's wrong because it's not a yellow bus, it's a yellow car here. But the description there is very expensive, means that it's very greater than image classification. Okay, of course we will not implement that. This one is quite tricky because they have another post processing to generate this text, but it's quite intelligent when you can see that you give any image, the system be able to describe in a sentence which is based on that information. Okay, I think for this one I can skip because it's similar to the previous class. Okay, just review back on what is an artificial neural network, and then the just to remind you, okay, in this in the previous class when we discussed about artificial neural network, we have done some heavy derivation on backpropagation and so on, and then the more emphasize on calculation and mathematical things there. But in this class, deep learning, we will not emphasize more on that because we already cover the fundamental at the previous lecture or the previous chapter, because the approach is similar. Because when we talk about backpropagation, the propagation is the same for backpropagation, but we don't highlight on the derivation because again, if you talk about the deep learning, like I said before, deep learning consists of more and more hidden layer. Of course, to derive by implementing do some derivation based on handwritten derivation is quite difficult. I think you need to have more and more many page to do that derivation. So I believe because we already know the fundamental, if the small unit of neuron can derive in that way, in order for you to do backpropagation. Now in deep learning, when we extend more and more layer, during the training process is also implement the backpropagation, the concept is similar. Just the difference is that the architecture become more and more bigger, the network become more and more bigger, the layer, you will have more and more hidden layer, but the backpropagation concept is similar. So that's why there's no derivation on that, because we already done the derivation in the previous chapter. So what we do is just try to show you the concept of CNN, how actually the process, how the data, how they calculate the data in terms of classification things. And the backpropagation I will not explain anymore, because it's similar to the backpropagation that we have learned in the previous chapter. Okay, so that's why the process is similar. There's a feed forward, the forward pass and backward pass, and so on. Okay, this is just some animation represent the A and N. Of course, if you discuss about this animation, what you think is not proper way to represent? Do you think is this a proper way to represent a neural network? I think it's not a proper way, because you can see that if this dog or this cat is in an image form, means that the input is image, so 3 input is not enough. Okay, because if this is the image, 3 input is not enough unless you have a feature extraction here, like a convolutional machine learning. Of course, this is a conventional machine learning A and N, so you need to have a human crafted feature here in order to do this job. Okay, because what is the attribute over here to represent dog and cat if you don't have feature extraction over here? So that's why this animation is a little bit is a little bit incorrect because of that. But for to make sure that, I think this figure have been this animation have been designed for, in order for you to understand a little bit about the machine learning. So then you know, oh, machine learning is used for learning something. The input, let's say the input is dog, and then the computer be able to learn and process actually and label that picture is belong to dog, or that image is belong to cat. But technically it cannot be done, because if this is the network, then you need a feature extraction to do that. Okay, because these three input is a feature, is a meaningful information, or you only limited your information with these 3 attribute. But to provide this attribute, you need one process which is called feature extraction to formulate the raw data and provide the meaningful features in terms of three-dimensional information, meaningful information, which will be fit into this network.